You know, it's kind of wild to think about, but what if the rules that run our entire world, your phone, the lights in your room, the whole power grid, could be found scribbled in an old student notebook? Well, today, we're going to see for ourselves. We're diving into these pages to uncover the principles that literally make our modern lives possible. So let's start at the very beginning.
Okay, let's open this thing up. We're starting with Chapter 1, right where the student did, the absolute basics. You have to understand this stuff because it's the bedrock for everything else we're going to talk about. First up, electric current. And the definition in here is just so simple and perfect. The flow of free electron. That's it. That's the what. It's the actual stuff moving through the wires. And we measure that flow in amperes, or, amps for short.
But what makes those electrons want to flow in the first place? Well, that's where voltage comes in. The notes call it the difference in electric potential energy. A simpler way to think about it? It's the push, the pressure. It's the force that gets the current going. And yeah, its unit is the volt. Makes sense.
Okay, so you've got the flow and you've got the push. But there's always something pushing back, right? That's resistance. The notes say it's the property that opposes the flow of electric current. It's basically the friction in the system, and we measure it in ohms.
Now, this is where it gets really elegant. These three ideas, current, voltage, and resistance, they aren't just separate concepts. They are perfectly locked together by this one simple, powerful rule, Ohm's law. It basically says that the current you get is directly tied to the voltage you apply. It's this beautiful little relationship that runs every simple circuit out there.
All right, so we've got the basics of electricity down, but right here in Chapter 2 of the notes, the story takes this incredible turn. Turns out, electricity isn't working alone. It's got this mysterious, invisible partner, magnetism.
And this is the heart of their relationship. It's a total two-way street. Get an electric current flowing, and boom, you create a magnetic field. But it also works in reverse. Move a wire through a magnetic field, and boom, you create an electric current. This perfect symmetry is literally the secret behind every electric motor and every power generator on the planet.
And you gotta love how the student drew this out to make sense of it all. These are Fleming's hand rules, and they help you figure out which way things are gonna go. It's pretty simple. The left-hand rule is for motors. It tells you which way the wire is gonna get pushed. And the right-hand rule is for generators. It tells you which way that new current is gonna flow.
So this magical trick of creating electricity out of thin air with a magnet, it has a name, and it's right here in the notes, plain as day, electromagnetic induction. This is how we generate massive amounts of power without needing a single battery.
Now, the guy who really figured this all out was Michael Faraday, and his laws, which are jotted down right here, tell us two absolutely crucial things. First, it's not just a magnetic field you need a changing magnetic field. And second, the faster you make that change, the more voltage you're going to get.
And here's the best part. This whole world-changing idea, it can be boiled down to this one incredibly powerful equation. Now, don't let the symbols scare you. It's just saying that the voltage you create, that's E, is based on the number of wire coils you have, times how fast that magnetic field is changing. That's it. That's the engine of our modern world, right there in one line.